I'll write the data at t equals 0. Now ft graph is there. Fx graph, okay. Area under ft graph. Change in momentum. And from momentum, can you calculate the speed? As from speed, work done as possible. So area under ft graph, what do we get? ma m dv by dt, or f dt equal to m dv. M dv is nothing but change in velocity here. So this will be area.
Change in momentum, no sir.
Yeah, change in momentum. So this will become m into initial velocity u, final velocity v. Okay, now I think we have some information. We'll get the speed. From there, we're going to calculate the kinetic energy. Area, I think we can calculate easily area. Net work done is needed, no? So initial kinetic energy plus net work done equal to final kinetic energy. Net work done is needed for, but what we can calculate area under curve is not net work done here. Change in momentum will get it. So what about the area? Area of trapezium, we'll calculate this. Initial momentum plus area equal to final momentum. V8, I'll write it. This will be 0. Area 6 by 2, 5 minus 2 plus area of that triangle minus of 2 plus 2, 3 equal to mass of the block 2 into V8. Why negative? Why this one positive, this negative? This area will be positive, no? This will be negative. I'll shade it. This correspond for this. This will
Sir,
correspond
half
for
h into
the.
a plus b, no sir.
Which one? Plus sign.
Yes,
Plus
sir.
sign. I forgot. 6 7 jar 42, 42, 21. 21 minus 3 equal to 2 V8.
V8 is 9, sir.
Now 0. Net work done we can calculate. Final kinetic energy will be 2 by 2 V8. From FT graph, area under FT graph is not equal to work done, is equal to change in momentum. From the change in momentum, we can calculate the speed. From the speed, we can get the kinetic energy. From kinetic energy, we can get the work done. All some interrelated. Huh? Even if I just put a statement is enough, student was supposed to work out. If they give kinetic energy versus time, kinetic energy as a function of time, then
Directly, sir.
directly no, you are able to measure kinetic energy straight away there. There's no necessity of anything. There's no necessity of anything. Work done you will get very easily by looking at kinetic energy there only. Increasing or decreasing. Work done positive or negative you can put in that interval. So some so very important, especially object, all this information is needed. A student must have awareness of from graphical information. In every chapter, the graphical analysis will come. Again, if AS graph, acceleration versus position graph, what you can get from acceleration of position graph? I think there v square minus u square by 2 is what area under AS graph. So directly you multiply m. So I'll give one more. From acceleration versus position graph.